For class 10 students, chapter 10 light. Last time I taught you about ray diagram by convex lens. First ray diagram I taught already, where object is kept at infinity, image is forming real, inverted, point size and forming on the right side. Remember that while convex lens, whatever image is forming, almost all are real, inverted and forming on the right side except one. Here the object is kept beyond center of curvature. We got the image, already taught you. I hope you have drawn already. This is third one, where object is kept at double of focus, and fourth one where object is kept between f1 and 2f1. These four sketches already I have explained to you. And whenever you will draw the sketch, three rules we are using. One rule, whenever the ray of light is going parallel to principal axis, after refraction it will pass through the focus. Whenever the ray of light is going through the optical center, after refraction it will be parallel to the principal axis. After refraction it will be remains undeviated. Whenever the ray of light is going through the optical center, after refraction it will be remains undeviated. And whenever the ray of light is going through the principal focus towards the lens, after refraction it will be parallel to principal axis. Out of these three rules, any two rules we will use it every time to get these images. Now next image, this one, by the convex lens, where object is kept exactly at first focus, f1. This is the object. Ray of light is going parallel to principal axis. After refraction it will pass through the focus. And when the ray of light is going through the optical center, it will be remains undeviated. So both the rays of lights are parallel to each other. That means the image is forming at infinity, very far away. It will be real, inverted and highly enlarged. Now last ray diagram by convex lens, where the object is kept between focus and optical center. And please remember that by the convex lens, whenever the ray of light, whenever the object is kept between optical center and the first principal focus, then it will be always virtual and erect image. This is the only one case. So here the object, whenever the ray of light is going parallel to the principal axis, after refraction it will pass through the focus, as if this ray is coming from this direction, coming from this A dash. Again, whenever the ray of light is going through the optical center, it will be remains undeviated. There will be no refraction, as if it is coming from this point. Both the dotted lines are meeting here. So here the image is forming, which is virtual, erect, forming on the same side as the object is kept, and it is beyond 2f. Yeah, beyond 2f1, beyond double of focus. So this is the only case when the object is kept between focus and optical center. Image will be virtual, erect, forming on the same side, and it is highly enlarged and forming beyond 2f, that is beyond center of curvature. Now by concave lens, only two images. One, when the object is kept at infinity, if the ray of lights are going parallel to principal axis, after refraction it will be going away, as if it is appearing to diverge from this f point. Same thing here also, as if appear to diverge from this point. Here the image will form, which is virtual, erect and point size, a diminished object, and forming at first principal focus f1. Here the object is kept at finite distance, that is between f1 and 2f1 the object is kept. When the ray of light is going parallel to principal axis, after refraction it will go away because of concave lens, as if it is coming from this focus. And when the ray of light is going through the optical center, it will be remains undeviated. Both are meeting each other here. So here the image will form, which is virtual, erect and smaller than the object and forming on the same side. So by concave lens, whatever image is forming, it will be forming on the same side. Now sign convention by spherical lenses and spherical mirror almost same. While starting the numerical problems, I'll give you this one, but lens formula for the time being, please prepare it. Lens formula is the relationship between image distance, object distance and focal length. The formula is 1 by v minus 1 by u equals to 1 by f. You don't need to derive this time. You don't need to prove it. Only memorize it. This formula is known as lens formula, which is the relationship between object distance, image distance and focal length. So 1 by v minus 1 by u equals to 1 by f. That is your lens formula. And earlier I told about mirror formula, 1 by V plus 1 by U equals to 1 by F. Now regarding magnification. Magnification produced by a lens similar to that of spherical mirror, and it is defined as the ratio of the height of the image to the height of the object. And magnification represented by the letter M. Here height of the object we is to mark by HO. So I am correcting this one. There also I have corrected height of the image and height of the object. So height of the image you write HI, and height of the object you please follow HO, because I'll be using this. Even here also HI by HO. HI by HO. Don't forget. So magnification means just to know whether the image will be bigger or smaller or same size. Just to know that we need to calculate magnification, and magnification can be defined as the height of the image to the height of the object. So M is equal to HI by HO, first formula, and with the help of object distance U and image distance V also we can calculate magnification. This time magnification will be V by U. For mirror it was minus V by U, here it is plus V by U. So magnification formula HI by HO equals to V by U. These numericals I'll teach you after some time through video only. Please learn the formula very well in these 2 pages. Now last topic regarding power of lens. For that one definition I am telling you. Please read these things by yourself. Now power of lens can be defined as the reciprocal of the focal length, which can be expressed in meters. Which can be expressed in terms of meters. So lens has particular power. To know that power we have a formula. Power of a lens can be defined as the reciprocal of the focal length, which can be expressed in terms of meter. So P is equal to 1 by F. Even you can remember F is equal to 1 by P also. But please remember that this F should be expressed in meter. This focal length should be expressed in terms of meter. Focal length should be expressed in terms of meter. Don't forget. And F is equal to 1 by P. And please remember that power of lens for concave lens will be always negative, and for convex lens power of lens will be always positive. And standard unit for power of lens is diopter. It is here. Standard unit for power of lens is diopter, which can be expressed in terms of letter D. Which can be expressed in terms of letter D. That means 1 by meter makes diopter. Your diopter makes 1 by meter. Because power of lens, your formula 1 by focal length, which can be expressed in terms of meter. That's why you can remember like this also. 1 by meter, which is your diopter. Yeah, 1 by diopter, which is your meter also. So please remember that standard unit for power of lens is diopter. It can be expressed in terms of the letter D. This is the only concept for this chapter 10. So explanation part of this chapter is completed. Numericals, everything I'll teach you. So study the textbook thoroughly. Read everything properly, perfectly. With this I'll conclude today. Bye.